Another example for us to look at, and we will use the quadratic formula to solve it. It is in standard form. There's our x squared, and along with the 6x squared we have the minus x. All of our terms are on the left side equals 0. It is in standard form, and now let's talk about a, b, and c. Remember that a is always the coefficient on x squared, so our a is a positive 6. B is always the coefficient of x. We have only 2 terms instead of our usual 3, so we have a missing term, but in this example what's missing is c, the number by itself. We have our x squared term and we have an x term. So I'm able to use for b in this example, b is a -1, but c, the number by itself, I don't see it, it's missing, so c is 0. There's our quadratic formula, that's a b. And let's start plugging in. Negative b is going to be negative 1. That will change to a positive 1. Inside the radical, b squared is -1 squared. Minus 4 times a is 6 times c is 0. All over 2 times a, 2 times 6. Let's start to simplify this expression. -1, that's positive 1, plus or minus. Now inside the radical, -1 squared, -1 times -1, positive 1, minus 4 times 6 is 24, times 0, that makes that entire product right here equal to 0. So in the radical it's 1 minus 0. 4 times 6 times 0. Just having a times 0 makes that entire product 0. Denominator is 12. So we're looking at, in the numerator, 1 plus or minus radical 1 over 12, and radical 1, square root of 1 equals 1. So we're back to an example where our radical, we were able to completely simplify it. And now we're looking at x equals 1 plus or minus 1 over 12. Remember what we like to do when the radical can be simplified. A good way to finish is to split this one up into 2 separate equations. One uses the plus, one uses the minus. So there's our plus, there's our minus, that's over 12. And let's simplify these expressions. That's a 1 plus 1 over 12, that's 2 over 12. And we can simplify that fraction down to 1/6. First solution. This equation, 1 minus 1 over 12, that's 0 over 12. 0 in the numerator is okay, it just makes it equal to 0. So there's our other solution. X equals 1/6, x equals 0. Both numbers, if we were to plug them in place of x in the original equation, it would make our equation true. Let's do one last example using the quadratic formula. It's in standard form. It's time to look for a, b, and c. A equals 1. B equals 2. C equals positive 11. And let's plug in. There's our quadratic formula. X equals negative b, that's going to be a -2, plus or minus the square root of b squared, 2 squared, minus 4 times a times c. A is 1, c is 11. This is all over 2a, 2 times 1. Let's start cleaning it up. -2 plus or minus. 2 squared is 4. minus 4 times 1 is 4, times 11 is 44, all over 2. Let's finish cleaning up inside that radical. 4 minus 44, negative 40 over 2. What do we like to do at this point? Two things. Simplify the radical, then simplify the fraction. Now let's look at this radical because for the first time we have a negative number inside of the radical. Can we do square roots of a negative number? What's the result of doing that? Negative number inside of a square root. This is going to turn out to be not a real number. You might get to a point where you start trying to actually simplify a square root of negative 40 using I to stand for the imaginary number, the square root of negative 1. And not everyone deals with complex numbers as we're learning to solve quadratic equations. So I'm not going to talk about complex numbers right now. I'm going to talk about what you would want to do when it's your first time through working with quadratic equations, solving quadratic equations. If you're not working with complex numbers yet, then what you would do when this occurs, and it can happen, negative number inside of a square root, we say there's no real solution. Once you start working with complex numbers, there is more you can do with this problem, but for now, that negative inside of the radical means no real solution. And that's it. There's no real number that I can plug in place of x in this original equation to make it true. No real solution.